over entities and entity pooling. So entities is very simple, right? You understand it's basically just any like object or thing that's an entity walking around the screen, or um, like it could be a player, it could be an enemy, it could be a bullet, it can be um, a crate, it could be an alien, a robot, anything that's in your game that's basically a thing, right? That's an entity. So when we go over to the docs, like most of the things that we have in terms of class are extended from entity. So the way Impact defines it is interactive objects in the game world are typically subclass from the base entity class, and an entity provides animation, drawing, and basic physics. And an entity pool is basically entities can be pooled and reused if needed. So let's go ahead and look at this entity class here. So here's a player entity, for example. It extends the base entity from IG, and it sets some properties like collides, ig.entity.collides.active. It sets type as ig.entity.type.a. Check against ig.entity.type.b. So types are basically when you want to kind of classify the entity into different types. For example, the enemies can be type B and the good guys can be type A, or something of that sort. We spoke in the earlier video on collisions about the different collides, which were none, or light, or passive, or active, and fixed. So those were the different types of collides that we spoke about. If you don't remember them or haven't seen them, go back and check out the collision video. And then we are defining the size of the entity here as 16 by 16 x and y. We're defining the health of this entity player as 50. We are defining an animation sheet for this entity, which is the player.png, with each frame being 16 by 16. We are setting up an init function, which is going to initialize this entity and add some animations from this animation sheet as idle and jump states. So again, if you don't understand this piece of code about add anim, go check out the video on animations that I created. And then it's basically calling the parent constructor. And the update function here is saying that if the ig.input.pressed jump, so we'll have another video where we define how to create inputs. But if the jump input is pressed, then we are going to say that the velocity is going to be a -100, and the y velocity, and the current animation is going to rewind the jump. And then we will call the parent, and the method is called for every frame, right? The update method, and it reacts to inputs or computes the entity's AI. And the call to the parent update will move the entity according to the physics. So this is basically creating an entity, and these interactive objects are, we said this already, right, and all of the methods listed can be overwritten in your subclass and called with this .parent if needed. The entity constructor basically will take the XY and the settings so XY is the position when you're creating an instance of this entity. So what we did here was we created the class, right, the entity player, and now here we are instantiating that player entity, for example. And so when we instantiate, we can pass in the settings that we want to set like the health or the velocity. And my entity, new entity, my entity class 00 settings, so it's where and what. And so Weltmeister can take this settings object to store additional settings for each entity. So the Weltmeister level editor basically allows you to add key value pairs for the different entities, and it basically goes in this settings object. Now the properties here, .accel.x, .accel.y is the acceleration to be added to the entity's velocity per second. Example, an entity with a velocity of x of 0 and acceleration of x of 10 will have a velocity x of 100 10 seconds later. So this is basically physics, where you are setting acceleration to change the velocity over time. So like you can set acceleration due to gravity, that kind of thing. Animation sheet, we have spoken about plenty in the animations. You use add anim to add these animations. Bounciness is a factor indicating with which force the entity will bounce back after a collision. So with a bounciness set to 1, the entity will bounce back with the same speed it hit the other entity based on that collision map. So if you remember, we spoke about the collisions, and we said that if, let's say, a passive entity hits an active entity, then they will both bounce. And if a fixed entity is hit by another entity, such as a light entity or an active entity, the fixed entity is going to stay in place and the other entity will bounce. So for stuff like that, the bounciness basically sets the entity's rate at which it kind of bounces back, the force. And check against is going to be one of IG entity type, type none, type A, type B, or both. The default is none. See the documentation for the type property. So one of the type here. Okay, I think we'll get to this type entity as we go down the list, so let's actually go back. But basically, you know that the types can be none, A, B, or both. So we'll come back to that. Or we can just say it now, I guess. Through the type property, entities can be organized into one of the two groups or none, and this is useful in conjunction with the check against property that we were just discussing. When two entities are overlapping and the check against property of one of the entities matches the type of the other one, the former entities.check method is called with the latter entity as the parameter. And you can, for instance, give all friendly entities type A and set up all the hostile entities to type check against A. In the check method of the hostile entity, you can then give the friendly entities damage. And the default is none. So, like I said, the good guys can be of type A, the bad guys can be of type B, and when the bad guys can check against A, and in the check method, the bad guys can damage the good guys, for example. This is an example of how to use this .type. All right, so we were basically on bounciness here, and then we were on check against. And then we have this collision. So we spoke in detail in the collision tutorial about these properties of never, light, passive, active, and fixed. Sorry, I might have said none instead of never, but okay, I guess the correct collides is collides.never. I think there was another .none for something else. Okay, so this property determines how the entity collides with other entities and is independent from the collision against a collision map. Inactive versus light or fixed versus any collisions. Only the weak entity moves, while the other one stays fixed. Inactive versus active. And active versus passive collisions, both entities move. And light or passive entities don't collide with one another at all. So the behavior of the fixed versus fixed collisions is undefined. Okay, so like fixed things should not be colliding with each other. For example, if you have an elevator which moves in place, it really shouldn't be colliding with another elevator that moves in place. Typically, entities that are unimportant for the game itself, such as particles, should collide light or never. Moving platforms should be collide fixed, and so that they're unaffected by other entities' movements, and so that. Okay, current anim is an instance of ig.animation that will be drawn by the entity's draw method, or null if no animation has been defined yet. So yeah, that's just for animating the entity, which we spoke plenty about animation. Now, friction.x, friction.y is the deceleration to be subtracted from the entity's velocity per second. Only applies if the acceleration is 0. So friction is basically negative acceleration, right? So you can't set negative acceleration and 0 acceleration at the same time. So yeah. Basically, friction is negative acceleration. I think this property is not necessary, but it's there. Gravity factor, how much this entity is affected by gravity. Again, this is a type of acceleration. And a gravity factor of 0 will make the entity float no matter what the game's gravity is set to, and the default is 1. Health. Health for this entity. An entity's health is typically decreased through the receive damage method. If the health reaches 0, the entity's kill method is called removing the entity from the game world. So you can keep the health of an entity and remove it using the kill method. ID represents a unique ID for this entity and is set by the entity's init method. Note that the ID of the entity might be different on each level load. Then, so basically the IDs are for the given level for the entity. Last X and last Y are the entity's position in the last frame before the update was called, and this is used for the entity versus entity collision response. Max velocity and max velocity in the Y direction is basically the maximum velocity that the entity can have. The default is 100. The minimum bounce velocity is 40 by default. If the entity's velocity is below this, the threshold of the minimum bounce velocity, it won't bounce back. So this is needed so an entity can come to a complete rest instead of bouncing back with a tiny velocity. Name specifies the name of the identity, and you can get identities by name using get entity by name. And it should be set through the constructor or in the Weltmeister level editor with the key value pair, and should be unique per level. So the default is null, which is no name, and then the offsets is basically the XY offsets of the entity's animations. If your entity's collision box size X and size Y is 8 pixels wide, but your animation frame size is 16 pixels wide, you specify an offset of 4 to shift the collision box 4 pixels to the right to center it on the animation frame. So if you got, I don't know if you got it, so basically there's the entity, and it has a collision box which is specified by the XY size. So let's say we have an entity with a collision box of 8 by 8 pixels, but your animation frame size is 16 pixels. So you specify an offset. Your animation frame size is 16 pixels wide. You specify an offset x of 4 to shift the collision box 4 pixels to the right to center it on the animation frame. Okay. Now the entity's position in the game world is given by position x and y. Size x, size y is the entity's size in pixels. And this is used for the collision detection and response. The default is 16. Standing, Boolean stating if the entity is resting on the ground on the y-axis. Slope standing, an object defining at which slope angle the standing property is still set. The default is slope standing at a minimum 44 degrees to radian and maximum of 136 degrees to radian. An object defining at which slope angle the standing property is set. So I haven't used this particular property, so I'm not sure. Type we spoke about for checking against these types and for the checks to see if we are colliding with friendly entities or with enemy entities. Current velocity is just vel.x, vel.y. So we basically saw position, size, velocity, acceleration, maximum velocity, minimum bounce velocity, and various factors like friction and gravity and health, bounciness. And then now we are on to the Z index, which is the drawing order. Entities with higher Z index will get drawn last, so they are going to be on top of the other in terms of the drawing. Note that the entities are by default only sorted once after the level load, so if you spawn entities after that, they will be appended to the end of the game's entities array and thus drawn last. So call ig.games.sort entities deferred to resort them. So if you set the Z index manually and you may need to resort them. Scalable or not, that is basically whether the entity size can be changed in Weltmeister. WM ignore. So these underscore WM properties are basically properties to help you with your Weltmeister level editor. Scalable, ignore, drawbox, box color. And methods are adding animation, which we saw, and angle to return the angle from the entity's center to the other entity's center. For example, if you were trying to shoot bullets down at something from above. Check is called to see if the entity overlaps with another entity and the other entity's type matches this entity's check against property. And the other parameter is the entity instance for the overlapping entity, collide with. This method is called when the entity collides with another entity. Handed over in the other parameter axis is collision axis, either X or Y. Draw, automatically called by the game for every frame and draws the current animation. Distance to returns the absolute distance in pixels from this entity center to the other entity center if you pass in the other entity as a parameter. Handle movement trace. We saw this earlier. It basically, when there's a collision, it allows us to get the result of that collision and handle. For example, if we wanted to play a sound or something, things like that we can do in the handle movement trace. So essentially we have to handle the movement trace when there's a collision, let's say with the floor, in this case kill. Remove the entity from the game world. This method is called by receive damage if the health is 0 or less. Could be used if you want to, for some reason, make entities disappear. Ready is a function that is called once a level has been completely loaded and all the entities are present. Use it to initialize connections between entities and such, and the default implementation of this function does nothing. Reset will basically be called in exchange for .init when the entity is revived from the pool or newly created. So pooling has to be explicitly enabled. See entity pooling. So I know I said that we'll do entity pooling and entity in the same one, but I think this video's got long enough, so I will do entity pooling in the next video. The default implementation for the .reset sets the .position.x and the .position.y properties to the given x and y, merges the settings into itself, and resets the following properties to the entity's defaults. Velocity x, velocity y, xl, xy, held, standing, type, check against, collides. Receive damage subtracts the amount of the entity's health and calls the kill method if it's 0 or below 0. And touches with other returns true if the entity touches another entity, otherwise false. Update, this method is called for each frame in the game before drawing, and the base entity's update method moves the entity according to its velocity, friction, bounciness, etc., and updates the current animation. This is the place to add your own logic for this entity, and if you overwrite this method, you can still call the base entity's update method with this .parent and see the synopsis, for example, which we already saw this example when we started. So this is basically the reference for entity. Let's see how big entity pool is. Actually, entity pool is pretty short, so let's just do it. So entity pool, basically here we have entity bullet, ig.entity.extend, some code, and that's basically our bullet. And then we are creating a pool and enabling it for the entity bullet. So basically all the bullets are pooled together in this one entity class. And ig.entityPool allows you to easily enable pooling for frequently used types of entities. This entity pool is global. You don't have to recreate it. You don't have to create it, but just enable it for your entities. And when reviving an entity from the pool, Impact will call the entity's reset method instead of the init method. Read more in the entity pooling article. Functions are enabled for entity class and drain pool with a class ID. So if we drain the pool with a class ID, it'll remove all the entities with that class ID, and enabling it will enable it for the particular type of class. Okay. I wonder how you get the class ID. I guess for entity, you just specify the entity in .class ID. All right. Drain all pools will drain all the entities from the pool. And this function is automatically called by the game's load level method before a new level is loaded. So loading a new level drains all of the pools of identities, I'm saying identities, entities. All right, so let's go and check out the entity pooling article. All right, so what is entity pooling? Entity pooling allows Impact to reuse these entities that have been killed in the game already instead of creating completely new ones. And so when pooling is enabled for an entity type and an instance of that entity is removed from the game world through .kill, this instance is put into a pool. The pool is essentially an array that collects these killed entities. Now, when you want to create a new entity, Impact first looks into the pool to see if there's already an entity of this type available and ready for reuse. If an entity is available in the pool, some of the properties are reset and the entity is removed from the pool and put back into the game. If there's no entity in the pool, Impact creates a new one as usual. So why do you want to pool? Sometimes you have an entity type that has a short lifetime and is spawned and killed very rapidly, like bullets. Some examples include all sorts of particles, projectiles from guns, or even some types of enemies. And so creating and releasing an entity can be a costly operation, especially on lower end hardware. And so each time an entity is killed and not reused, it becomes garbage and will eventually be collected by the JS garbage collector. And garbage collector GC takes time and can cause some intermittent pauses in your game, so you should try to create as little garbage as possible, and pooling helps with that. So pooling only makes sense for entities that are frequently created and removed again, and for instances, enabling pooling for your player entity probably won't make any difference at all, because there's only one instance around at all times, and player death doesn't happen frequently in most kinds of games anyway. So on the other hand, if you have a bullet hell shooter where hundreds of bullets are being spawned and removed again, by all means use pooling. So using this IG entity pooling basically is very easy. To enable pooling, all you have to do is require impact entity pool and a reset method that is called when the entity is revived from the pool, and call the IG entity pool enable for entity class. So for instance, if you have a bullet entity for which you want to enable pooling, it would work like this. So we have created a bullet module, required entity and entity pool. We have defined an entity bullet, which is creating its animation sheet and its shooting sound, and initializing it with an idle animation. And when we reset it, we basically are just calling this .parent. This function is called when the instance of the class is resurrected from the entity pool. The parent implementation of reset will reset the position to the given XY and will reset the velocity, acceleration, and health, and some other properties. Play the shoot sound again. Remember, init is never called when the entity is revived from the pool. So essentially, when we are resetting the bullet entity, what we're doing is we are resetting its velocity, acceleration, health, and whatever those kind of properties, and we are creating the bullet sound. And essentially we can keep collecting the bullets and reusing them rather than forcing the garbage collection on them. And then to enable the pooling, we just simply do ig.entityPool.enable for entity bullet. So with the pooling enabled, you can just spawn your entity like the usual, and Impact will figure out the rest. So you can do ig.game.spawn entity bullet, provide the X and Y position, and the settings array for the bullet, which is whatever other properties we might have set. You can even use the normal constructor for your entity, var bullet equals new entity bullet XY settings if you need this for your game for some reason. For a concrete example, you can see the generic jump and run example game in the download page. The fireball entity in this game uses pooling. Also see the documentation for entity pool for more details, which we already saw. All right, so we are done with entity and entity pools, or pooling. So entity pool, entity, and I will see you in the next video. So we have now covered starting from here. I don't think I went over core. Okay, so I haven't yet done core. So maybe in the next video we can do core. We've done animation sheets, we've done background map, we did class, we did collision map, we did entity pool, we did font. So, okay, so next one we can do for core and we can do game. And then we already did image, music, sound manager. We already did map and loader as well. So what remains is input, core, game, system, and timer. And we will do these classes in the next upcoming lessons. And let me see if there's more on these tutorials. Yeah, so debugging, baking, drop source code for a game, these kind of things we may do later. Physics with Box 2D, and tools, libraries. So I think we're making good progress. We are, if you've seen all the previous videos and you're on this one, you're getting there in terms of knowing the library and getting ready to start using it to create games. Enjoy, and I will see you in the next one where we will discuss core and game and system perhaps